Okay, welcome back. We just finished the applicative exercises, and it was a long one. And so now comes the big doozy. We're going to be doing monads. Oh boy, can we do it? I hope I'm not here until midnight. Without further ado, let's just jump right into it. Not going to even dilly-dally. So, monad. Maybe let's review the types. Just to get a sense of where we're at. So applicative has pure, which is A to K, like wraps some value in a context. And then apply has this signature, which is some context around a function, some context around a value, and it produces a new value inside of that context. So I'm just going to grab this and I'm going to throw it in here. And then what I'm also going to do is take functor, and I'm going to grab the signature for functor, for fmap, excuse me, which just takes a function not inside some context, a value in some context, and produces a context. And I'm just going to line these up. This is obviously not something I came up with to display them like this. Seen multiple people do this, but I think it's very helpful. See what's going on. So, okay, so if we take bind here, which we haven't talked about, I know that. I'm just going to go through and show kind of like how these are similar. So, just going to like rearrange the spacing here. So we can see how similar these are. Fmap just takes a regular function, a value in a context, and produces a value in a context. Apply takes a function in some context and a value in some context. So the difference is the functions in the same context. And then this function, which we'll call bind, takes a regular value and returns a value inside of a context. And then a value in some context. And so what it's doing here is like unwrapping this a value and then applying this function, and then you're done. There's no need to rewrap it. Like in both of these cases, you need to unpack this value, run the function. And in the case of apply, you have to unwrap the function as well. Maybe unwrap is not the best word because we've already talked about how the container intuition doesn't always hold. It breaks when you're talking about certain things like functions as functors. And we should also keep in mind all applicatives are functors and all monads are applicatives. But where's my train of thought? Yeah, basically, so we unwrap this value and we pass it through this function and we're done. And let's see, all instances of the monad type class must satisfy one law. This law is not checked by the compiler. This law is given as the law of associativity. So for all f, g, and x's, g binded or bound bound with the result of f bound to x is equivalent to I guess binding g composed with f bound to x. So let's see, how can I express that in my own words? So I guess binding x to f and then binding it to g is the same as composing creating a new function by composing f, and then whatever the result of f is, you pass it through, you bind it to g, but you take f and bind g, and then you compose that into a function, and then you bind x to it. So it's similar to the, let's see, let's look at the laws for here. Composition. Associativity. Okay, so maybe that's where I should have started. So evaluating this right side, you can evaluate this right side or this left side first. Doesn't matter. And that's similar to, if anyone's not familiar with the concept of associativity or this word, you do know associativity. You just might not have known the word for it. But addition on numbers is associative because you can add this left side 1 plus 2 first, or you can add this right side first, and it's the same thing. And so lots of operations are associative with certain data types. So like multiplication is associative, because if you just had all multiple, if you change the pluses to multiply, then it doesn't matter the order. Trying to think of other examples, like taking the minimum. So if instead of like plus, we had like min, I think that's a thing. Whoops. T min. Yeah, so I can take the minimum of 2. So if I did something like min, whoops, then this is going to return 1, and then we're going to take the 1, and the minimum between 1 and 3 is 1. And then if we apply this side first, then the result of this is 2, and we're going to do 1 min 2, and that's still going to be 1. So in this case, it'd be 1. So lots of operations are associative. That's what I'm saying. So I guess bind is saying it doesn't matter the order you bind things. It's interesting. Okay, I think I'm just going to start solving. So, how's everyone doing? Anyone out there? BR Brown. Hey, welcome to the stream. I'm going to creepily spy on you with my Twitch streamer powers. I can see who's in the chat. Hope that's not awkward. Okay, so first we're going to implement the monad instance for exactly 1. So I'm just going to do what I always do here and say, just do a type tool. So exactly 1a. So I'm going to put to do here, reload. Okay, so hey, BR Brown. How's it going? Staying safe out there? I think weather is getting back to normal for everybody. Spy away. Yeah. Okay, so to do, this should be an exactly 1b, obviously. And I can get an exactly 1b by taking the a embedded here and passing it through f. So I'm just going to pattern match exactly 1a. Whoops. And then apply f to a. And since f already reconstructs a value into exactly 1 for me, then I think I'm done. Let's check that. I think I'm gonna maybe boost the font a little bit, since I I think it's best if I just do one window at a time. So BR Brown says it's a nice 50 here in South Carolina. That is nice. It's really warm today here in the Nashville area. I mean, we got blasted with the blizzard, and then I mean, it was crazy. I've never seen snow like that in Tennessee, and but it's almost completely melted now. It's been a crazy change in temperature in a very short amount of time. So let's see. Let's do test exactly one test. Well, I think I have not loaded the right module for this. So I'm going to do monad test. I'm going to test exactly one exactly. It's not finding the test for this. So maybe I'll look at the monad test module. Bind exactly one test. That's what it's called. Okay, that passed. I'm just going to run it like so. So let me glance at this syntax a little bit. So this less value is a function that takes an x and returns an exactly one x plus 1. So that fits our signature here. And then this right side is just a KA basically. And then yeah, and this bind. Okay. So it is, yeah, it is an infix just like the other ones. So let's run this. Okay. Yeah, so it's very similar to what we've seen before. So I mean, it'd be very similar if we did exactly one plus 1 applied to exactly 1 2, except of course it's going to make us wrap everything in prints, I think. No, it's because we haven't added the applicative module where that's defined. So from integer. Oh boy. All the type problems. Yeah, I mean, we did demonstrate this though. So we had an exactly one, and we did apply like this. Wonder why it's not working for me. Maybe I need to first load some module. Yeah, I think that's why. Mr. Brown, are you familiar with Haskell? Do you use Haskell like professionally or just as a hobbyist? Curious. BR Brown is a friend from the co-recursive Slack. So anyone who's not familiar, you should definitely check out the co-recursive podcast, which I'm going to pull up quickly. Really great community of people, and yeah, I was quite shocked to find such a friendly group of people like via podcasts, and just like decided one day I'll join the Slack channel for this podcast, and made a lot of friends. So highly recommend you check out the podcast, and if you're so inclined, you could join us on the Slack channel. Let's see. Co-recursive. My computer's being slow. All Scala and Python, says Mr. Brown. But I guess coming from Scala, you're familiar with a lot of these more advanced category theory, like algebraic data types and stuff like this. BR Brown, but Haskell's on my list to explore. Yeah, it is an awesome community for sure. So, coworkers of podcast. I just want to give this a shout out. Actually, in the first part 1 of this series, I'm doing Adam Gordon Bell, the host, like jumped on. That was very nice of him. So, all right, yeah, highly recommend it. So, let's move on to the next exercise. And if you have any questions, I think, if I'm not mistaken, your first name is Brandon. I'm sorry to have to ask that. I think all your usernames are like BR Brown. Hope you don't mind me using your name. But yeah, if you have any questions, please let me know. That's kind of the point of this, is like try to think out loud, and people can correct me or ask me questions and help me to have to explain it out loud. Monads are still magical to me, but making more sense as I go. Yeah, same. Okay, monad. Got distracted. Okay, monad instance for list. So A to list B, list A, list B. And this looks very familiar to me because we needed to do something similar here, where when we defined the applicative instance for list, we had these two lists, and we ended up using flat map. So if I look at flat map from our list module that we did, flat map, if I can find it, look at this. So flat map has this type signature. Actually, I'm just going to copy it over. So it has this exact type signature. So I mean, the whole point of a flat map is you have a function. Let's say I want to go from, just trying to think of something non-trivial. Well, let's say I want to have a function that like takes an x and returns like 2x's or 3x's in a list, say, just, or 2x's in a list, just for whatever reason. And then I have a list of y's, like y1, y2, y3, or whatever. If I map, let's say this is f. If I map f over y's here, then I'm going to get a list of lists, because this is going to be like, it's basically going to look like this: y1, y1, y2, y2. But if I don't want that, if I just want not a list of lists, but I want just a regular list, then I need to map and then flatten. And so that's basically what flat map does. Yeah. So I think we can just drop flat map in. And I think I'm going to do it and then see if the test pass. Test bind list. Monad test. Bind list test is what it should be called. Oh, maybe because I re-added, I changed the target set. I'm still figuring out how to use GHCI. So I'm going to add back this monad test module. And then if I do test bind list test, that passes. So the instance So the implementation for bind for the list monad is just flat map because it basically achieves what you need it to. So let's run this expression. Yeah, so this is basically what I was just saying. So we take some value and just append it to itself in a list, and we have some list. We can bind the list to this function, and then it produces this value. So it's hard to like feel why this is important or why this would be useful. Just starting out, like for lists in particular. So, I mean, I think the best intuition I have for it is promises in JavaScript, which aren't exactly this. The way that promises work don't exactly behave like this. I think because promises automatically join themselves, like you can't have a promise of a promise. I forgot that I like kind of cropped my camera a little bit to show more screen, so I need to be careful about where I put my face. Yeah, so with a promise, it's like I want to bind because a bind is kind of like a dot then, I guess, because it's like once this resolves into some value, like I'm going to take some promise and then eventually I'll have some value that I can then run another promise on, like a promise chain. But if the first one fails, then there's some kind of handling, like it goes to the catch block instead. And so I think there's kind of that notion of you're wrapping up all of the handling of this particular data type inside bind. So that was probably a horrible way to explain it, but like I said, thinking out loud. So we'll persist and see where we go. So same thing, except now with optional. Just going to go the type tool route. And okay, so we need optional B, we have an optional A, and we have this function. So we need to get at this A value inside the optional A. And I could do that by pattern matching. Maybe I'll start with pattern matching just to demonstrate it. So the optional A is either empty or it's a full A. If it's empty, I mean, I can't use it, so I'll just return empty. Just like I imagine if we bind over an empty list, we just return an empty list. Let me try that. Oh, it's not in scope because this is not implemented and it's not compiling. So I'm going to throw undefined in there, reload. Hello, Pedro, how's it going? Okay, yeah, so binding on an empty list is just an empty list. So that's going to be a very similar thing for optional, which is kind of like a list with a maximum length of 1. So it can be empty or it can have its one element. So in the case where it does have its element, then we just apply F to A. And since F already puts it back into an optional, we're done. And that's very similar to the exactly one here, where we just unwrap it and apply the function. So then let's refresh, test, bind, not exactly one, but bind optional test, failed. Undefined, bind for optional. Pedro asks, all right, how about you? I'm doing okay. I'm trying to learn about monads. And the other exciting news is I originally started the stream just as like a way to outsource my accountability to, it's like, I want to go through this course, and I know if I like start streaming it, then I'll want to like keep going. Uh, and I'll like have to stay focused, almost like pair programming. I feel like when I pair program with coworkers and whatnot, it's like I can't, you know, just get distracted, like open a tab and go to, some website and start wasting my time, or I can't go on to Slack because there's someone there with me. And so I feel like knowing there's people out there and chatting with people on Twitch, it's like keeps me focused. But I wanted to try it before I like invested a lot of time and effort into my setup or like learning about how to stream. I wanted to try it. So I've tried it and I really like it. It's not like I have hundreds of viewers or anything, but I'm really enjoying it. So I finally pulled the trigger and like bought some like equipment today. So I'm going to be switching off of this super old computer I'm using, which I apologize to everyone for the speed of like how long everything takes to do on this computer. But hopefully that will be alleviated soon and I'll have better like video quality and streaming quality. So I'm excited about that. But yes, the monads, the M word, let's get back to it. So optional. Okay, so I think we just passed this. Yeah, why isn't this working? So defined for optional, prelude, undefined. Okay, so we left that. Oh, I just didn't save the stupid file. That's why. Okay. Okay, that passes. So let's try it out. Got our function here. So this function takes some value and adds it to itself and wraps it in a full, like puts it in an optional. And then if we bind 7 to that, then it doubles it. So if we do 10, it should be 20. Okay, simple enough. But from the optional module, there's a function called optional, the same name, but with the lowercase o. Pedro says, Graham Hutton got a Haskell course going on YouTube. Ah, I will have to check that out. I'll open a tab so don't forget. Graham Hutton. I think I've seen his number file videos where he talks about monads and various Haskell things. See, that's what I'm talking about. Like, this is so slow. Loading so slow. Okay. Coursework 1. 15 hours ago. Nice. Yeah, we'll definitely be checking this out. Thank you for telling me about that. So this optional function is very similar to like fold right. So I think we can do this instead of pattern matching. So I will comment this out. It takes an F and an optional A. I think we'll be able to add or reduce this away. So this, we can do constructor replacement. So we replace the full constructor and the empty constructor, and then we give it some optional value. So that's what this function A to B, and then some B, and then some optional value, and it returns a B. So I can just remove these the OA on both sides at a reduction, and then for empty it stays empty. We've already seen that right here for the empty case. So for full it's just F. That's all it is. And then yeah, F already repackages it into an optional. So we can just do this instead of pattern matching, because this optional function kind of like does the pattern matching for us. So test by an optional pass. Okay, cool. Nice, cruising. I feel like I'm going a little bit faster this time, which is good. Oh man, okay, so monad instance for the function. Computer file. The monad for division by 0 is pretty bad. Yeah. Is that the one he covers in that video? Like, divide by 0 monad? Because the regular Haskell divide, like this is like integer division, so I think it just rounds. It's like 4 divided by 3. No, that does. Let's see what type x is. Fractional. Fractional. Okay, so fractional is something that implements divide and recip. And from rational. Okay. What if I do like 4 divided by 0? Oh, it's infinity. That's interesting. Huh. I wonder which mathematical operation this is closest to. I mean, is it div? Div is integer division, so div? Integral. So then 4 div 3, I have to use the backticks. Okay, so this is integer division. So is this... So this is like kind of like modulo, but instead of the remainder, it's just how many, yeah. It's like 3 goes into 5 once. Div 6, 3 is 2, 4, 3. Yeah. Okay. So then what happens if we divide by 0? Boom. Okay. Div 7, 2. Yeah. Okay. So then, yeah, do some languages have like a safe div, right? I don't think that's a thing. But you can implement your own. I think it's the same story for head. Which we didn't do head, we implemented head or for this course, which is in the list module. List. So head or, yeah, so we have to give a default. So we have to say like head or, and then if we give it a nil list, we have some default to give to it. But I think in regular Haskell, let me start up GHCI in a different context. Pedro says head is not in the course, but prelude head errors with exception. Okay. Yeah, so if we do head 1, 2, 3, then we get 1. But if we do head on empty list, boom. Cool. I see. Okay, so I feel like this is gonna be it's gonna be a doozy. I'm gonna rewrite this because I find it really hard to read the prefix version of this function arrow. Okay. I need to leave this paren here. So I'm reading this as given a function which takes a value into a function, and given a function, given a function that takes an a and returns a b, and a function that takes an a and returns a function that returns a b, and then given a function that returns an a, return a function that returns a b. So what do I call this? I'm just gonna say ATB and TA, and just to get a start somewhere, and throw in this type tool, reload. So okay, so I need a function that returns a b. So let me just follow this. So supposing I had a t, I'm going to create a lambda that takes a t and returns a to-do, which should be a b, right? Yeah. How do I get a b? Well, the only way to get a b is from this ATB. So but I need to pass ATB, in order to return a b, it needs to take an a and some t, which I'm going to call t prime, and give it Am I thinking about this right? So in order to return a b, so I can even take these prints away, and maybe that helps. So in order to return a b, I need a t. So supposing I had one, what would I do with it? Well, I would pass it into this function, which returns an a. No, is that the right way? Yeah, that's right. So supposing I had a t, I would pass it into this TA function. TA takes a t and returns an a. So the evaluation of this like little parenthetical should be an a. So now I have an a. So I could pass that into this ATB function, pass the result of this into ATB, and that should return a TB. But I need just a b. So then I need to apply this whole thing to t again. Let's see if that works. Well, it compiles. Kind of surprised actually that it compiles. Test function, bind function. Maybe it's called reader. What is this called? Bind reader test. It's not in the target set. Test reader. Why is it not there? start over here. Load source course monad. Pedro says that's correct. So I believe Pedro. Pedro, which is the correct pronunciation. Apologies. Bind reader test. Haha, okay, that works. That does work. Okay. So let's see what hlen is telling me to do. Redundant lambda replace with this. Okay, yeah, so I don't need these outer parens. And then this is like edit reduction, right? I don't need the t on both sides. Replace with. I'm having a hard time reading this. I think it's saying I don't need these parens. Let's see. And then, okay, it's still recommending replace with. Okay, so it's saying just put the t on this side and remove the lambda. So let's do it. Let's do another. Let's do another compile, just to make sure. Okay, that still passes. So then, can I edit reduce this? No, because I can't. I still need the t right here. So I kind of want to just call this like f, and this g, and then this x. Is that bad? I just find that like easier to read. So then we take this f with this signature, g with this signature. We apply g to x. Can you copy and paste the signature? I actually don't have Twitch, but I can type it in. I don't have Twitch running on this computer just to save bandwidth. T B. So I think, yeah, I think that works. Okay. I'll be interested to see what the solutions, like Tony Morris's repo, like with the solutions, what he does here. Okay. This I'm wondering too if this is some combinator. Just like in applicative, we saw that with the applicative instance for function or the reader, this is like the S combinator and this is the K combinator. I wonder if there's some special relationship with these. That would be interesting. Okay. Oh, my file wasn't saved before that last compile. I think it is now. Let's see. Okay, yeah, passes. So then witness that all things with bind. I guess I should point out too that this is left bind. Like usually in Haskell, bind is written as this, which I think is below in the course. So bind is just this, and this could just be flip this thing. Flip. So it just takes the value first and then some function. And this is kind of even more like what we're talking about with JavaScript promises. So like you take some promise and then some callback, and then you like produce some other promise. So I'm just gonna comment that out. I think this is actually in the course. Like, yeah, it's down here. So we'll get to that. So this is saying witness that all things with bind and fmap also have apply. So we're going to re-implement this apply, just a different, put two splats just to have a different thing. So Pedro says bind is like fmap. Fmap fv is like f bind v. So are you saying bind is like fmap? Like it's the same? I know it's similar, but what do you mean by like it's like fmap? I mean, it certainly is very similar in its type signature. The order of the argument. Yeah. Left bind is closer to. I mean, it just lines up so nicely with fmap and apply. I'm pretty sure that's why they have you do left bind. But in practice, right, this regular bind or right bind, I guess, is more useful in practice. So, okay, so let's implement apply in terms of bind. I think that's what this says to do. Witness that this is the case. Okay, I will witness that. Yeah, so it's just apply. Okay, so I have some kf and some ka. We need a kb. And let's peek back here and see how we did it for some of these. So yeah, it's just basically unpack the values and then apply the function to the value and then wrap it back up. But since these are monads, I mean, the only thing we know to do with them is to left bind. I mean, because we don't know anything else about this. So so if I bind this, I'll just put it to do. Well, first let me put it to do here. It's always good. Yeah, okay, so I think that what's happening is it's just slow to save the file, and that's, maybe I'm too fast for my own good. So I need a KB, I have this KA and this KF. So let's say I bound KF. What would this to do be? I don't know if that's gonna. So to do needs to be this. So basically we've bound this KF. So we've kind of gone inside this K context, and now we have we kind of have access now to this function. So we have this A to B. So let's say, supposing we had this function using a lambda, Let's just keep going. Follow the types. Pluminator, hey, thanks for hopping on. Yeah, we are witnessing. We have been told to witness that all things with left bind and fmap also have apply. So that's what we are doing. We're witnessing. So, and you'd be proud of me. I'm following the types. You always tell me to follow the types. So, I have this f now, which is an a to b, and I need a kb. I can't create a kb, but I could create a b if I had an a. And since I'm bound inside this context, it's kind of like when I come out of it, when I return from this lambda, I'm going to be like still inside that context. So now I have this a to b function, which came from this kf, and now I need to get at this a inside this ka. That's kind of how I think about it. So, so now I'm going to bind this ka and see what to do is. I have a ka. So now a to kb. So supposing I had an a. Need to return a kb. So now I finally have this a and I have this f which takes an a. So if I apply f to a, but then the whole tells me I need a kb and I can get a b. Does that mean I need to like use like pure here? Let's just see if this compiles first. Okay, it doesn't compile. Yeah, because expected a to kb, not k. I mean k of a to kb, not ka to b. Or do I just fmap here? Yeah. So maybe I went too far. Let me think. I don't want to bind there. So let's see. I need to return a KB from here. And I have a KA. Okay, so then if I fmap this function onto this KA, then I can like reach inside this context and turn this A into a B. So then I just do fmap KA. And I think that's it. Yes. Yes. Okay, so then there's this app test. Yeah, okay, there we go. Boom. So yeah, that's why it's saying all things with bind in fmap have apply, because you can implement apply with those. So now let's try to reduce this into something cooler. So I could just do this infix. Okay. Cool. So it's like, this is just saying bind this, you get an F, and then F map it onto KA. Neat. Cool. Next problem. Okay, join. So join is like flatten. So if you join two lists, you just get a single list. If you join two optionals, you get a single optional. So you can join a function to a value. And it like the 7 gets put on both sides of the plus. That's kind of blows my mind. Maybe one of you will have to explain that to me. Yeah, this kind of blows my mind. But let's see how far we can get. So I mean, this typed hole is really going to help me much here. Let's see. KA. So I need a KA and I have a KKA. It's not very helpful. I guess the only thing I know about it is I can bind it. Puminator says it's the function monad. This is the function monad. So the instance of monad for reader T or function. So you have an F and a G and an X, and you apply G to X, and then you apply F to the result of that and X. So it's like X gets used twice. You only pass it in once, but X is getting used twice. So it's let me see. If this was plus takes two values and returns a third value. So if you joined plus on, but 7 isn't a function. That's where I'm getting lost, because how does this even match the type signature? Well, no, join. Okay, it's join. It's not bind. So I don't know. Pluminator says it's F applied to FA, where F is the like reader of A. Drop the 7. Drop the 7 and it makes sense. Okay, let's go back. Join returns a function in this case. Okay, so let me implement join first, and then maybe that'll help. So I have this. It's kind of like double wrapped. I mean, all I know is that it's a monad, so I'll bind it. So then, okay, so I need a KA to KA. That's just ID, right? Yeah, valid whole fits include ID. That compiles. Test, join, test. Okay, that passes. So then let's try it. Yeah, what the heck? Pedro says GHC makes it too easy. What, with like the type tolls make it too easy? Pluminator says I like to pronounce KKA like predator. I don't know if I get that. Check the type of join plus. I will do that. Type of join plus. Join plus is a function from A to A. So like you could give it an int and it returns an int, which is what we see here. So if KKA is plus, I don't understand what it means to so then we're binding on plus. So let's KKKKKA, the noise that predator makes. Okay. That's why I think of it as predator. Pedro is in the same boat as me. Didn't help. That didn't help. Brandon says, I know the person who did the footsteps of the predator. Like the sound of the footsteps? Or like the walking? Like the person who was in the suit? That's a pretty cool trivia fact. Say uh like imagine doing two truths and a lie and saying I did the footsteps for the predator. That's pretty sweet. Yeah, so let me break down. So we just did bind on the plus operator. So let's look at this again. So plus is like kind of like a reader T. It's like a function. This is the function monad instance. So if you bind on plus, and ID, is it I? Okay, so if we call bind ID and we pass ID and plus to bind, so then this would be ID and this would be plus. So then F is ID and then G is plus. So then we get some 7. And plus 7 returns a function, A to A, or like num A to num A. And X is still 7 here. So then this is saying like plus 7, 7, and then this is just ID. So let me go through this. So let's say we did ID KKA 7. Then F becomes ID. This becomes KKA. No, not KKA, I was going to say plus. Yeah, so join, wow, it's really bizarre. Let me catch up on the chat here. Repeating here. It's F applied to FA, where F is reader A. I think I can hack some type applications that will clarify it. So plus is plus 7, 7. Yeah, the person who did the Foley footsteps, and she did John McClane in Die Hard. Wow, that's funny. You have some cool friends. I think walking through this clarified it for me. So because join is binding, how would you pronounce that correctly, or like enunciate this? So join is like binding some monad to ID, or binding ID to some monad. I don't know what the right way to say it is. And because bind for functions has this pattern of applying the value twice. So, or as Pluminator says, F applied to FA, where F is some reader. So F applied to FA, where A equals, no, where, sorry, excuse me, where F equals like reader A. I still don't like understand this though. I have a hard time reading this. It's like a partially applied function. I mean, I think I don't understand it because I like can't type it into GHCI. Pluminator. I think of join as flatten. So plus 7 7 is flattening the function application. Oh, arrow A is the type of a function that returns A. Okay. That's kind of bizarre to think of. So when you all are saying plus 7 7, I guess when we broke this down, we only have a single plus, because plus takes 2 arguments, so we don't need the second plus. But I guess ID, is that what you're saying? Or no, ID is, either way. I mean, it's it's associative, right? So we can evaluate this side and it's 14, and then ID on 14, or it's ID on this function plus 7, which is just plus 7, and then we get 14. Okay. Yeah, all this stuff with like the type class instances for function are always kind of mind-blowing. Like this one. Okay, I'm gonna keep going so that I'm not streaming for hours and hours. Suppose the plus in my notation is the type. Oh, I see. Okay, let's keep going. If you still have, if you have more thoughts about join and the monad instance for function, like, please share them. I'm just gonna keep moving on, and I'll follow up with the chat. So implement a flipped version of left bind. However, use only join and fmap. I mean, Okay, I feel like I could just, it says it just wants me to use join and fmap, but I can't help it. I gotta see this compile. So flip, bind flip test. Okay, that does pass. That satisfies me. Okay, so now let's do it the way they say. So we have this Ka and an F. Okay, so yeah, so then if we fmap F on Ka, so we kind of inject this function into this context and change this A into a KB, then we'll have a KKB, which this will evaluate to a KKB. And just to demonstrate that, maybe I can say, I'll just apply a function with a hole to the result of this, just to see what's in there. Yeah, so to do is A to B, and X, I think I need to wrap this. Yeah, okay, so this is what I was expecting. So K is now this, no, X is now this KKB, and I need to return a KB. But I have this join function now, which would flatten this basically. So I could say join X, or just join this. I think this will work. Yeah, okay, that works. Very cool. So then could I get really fancy here and say, like, if I flip fmap, so it takes these in reverse order and then compose that with join? Let me see. If I flip this and then compose it, will that work? Join flip fmap. I'm going to be so impressed with myself if this works. I don't think it's going to work. Why doesn't that work though? Because maybe I should approach it this way. So if I say join this passes. I don't know, I want to be like a Haskell wizard that can like point free things. So let me write this infix. So then, I mean prefix, I always mix this up. So if I write this prefix, I can nearly like reduce this. So it feels like I should just be able to flip fmap, right? And then now it should take Ka and F. That compiles. Oh shoot, that works. Okay. Let's see. So can I just remove these now? And then change the $sign to compose? I thought that's what I had though. Illuminator says, I'm gonna write this down as I read it. So plus has the type arrow int. How do I read this? Is it reader int? Is that how I pronounce that? Int. I do need to show the chat in my stream. I will do that once I get the equipment that I ordered today, and I have a computer more capable. So plus has this type, arrow or function. So arrow int. Okay, so plus usually has this. So we can write this in prefix notation like this, basically, I think is what you're saying. But let's start from the right. So this we can write as prefix by saying this and wrapping these in parens. But then we can write this one in prefix by taking this here, putting it here, wrapping it in parens. And then we need to wrap this in parens. Probably. Ah, yeah, that's so weird to read though. I can't really read that. Pedro got it in course. Yeah, I really wish I had chat on stream because I'm not going to be able to read that out loud. It's too complicated. uh, the comment describes it. Read it as, Pluminator says, read it as an int returning function nested in another int returning function. Okay. So it's like an int returning function. So if I read, you said to read this as a function that returns an A type. This is the type of a function that returns an A. But then that means, could I read this as the type of a function that returns two A's? That doesn't make sense to me. Maybe you can explain that to me. Okay, so I can remove some of these brackets. Wait, is this not working again now? I thought we had this working. Or maybe it hadn't like saved yet. Dang. Anyways. Yeah, I thought I had this working. Pedro says check the gist. T plus V join. Doesn't seem to want to run. Yeah, is there some language extension? Oh, sorry, set. Okay, so let me go to GHCI. And I need to do set X type applications F print explicit for alls. Restarting this. Hopefully my history is still there. Pluminator says this doesn't work without the language extension. Well, I'll try it. I'll try it and see what happens. Let me load course monad. It's getting warm. Okay, so that returns some type information. So the type, what does plus V mean? I don't know what plus V means. So is this saying the type of like join function int? Oh, verbose. Plus V is verbose. Okay. So what happens if I take that out? Okay, for all A, into A, given an int returns an A. So what is the type of just this thing? It's not working for Pluminator. He's on GHC 865. I think I'm on actually I'm not sure how to show. I'm not sure which GHCI version. Maybe I would just do GHCI version. Whoa. I'm just going to kill that. Don't know what's happening there. Anyways, okay. You have to bind the return type. You have to bind the return type, I think. Is that what the @ sign is doing? Nathaniel says it'll print the version when the REPL starts. Okay, so maybe I'll just do that. It takes so long. I really want one of those M1 MacBooks. Wife says, why don't you just use this PC built like last year? Because it's not an M1 MacBook, that's why. Yeah, I'm going to try getting this all set up on Linux. I think that'd be fun. Maybe I should do a video of me setting it up on Linux and post that in case anyone needs the help. Okay, I totally was not watching. Yeah, 865. So I should be the same as you, Pluminator, and I added this to my GHCI, and this thing works, and I can add this verbose flag. That's cool. I didn't know about the verbose flag. So let me look at something simpler, like I don't know, join. It's not that different, I guess, for some things. I guess it shows the kind. Okay, I'm gonna go on to the next exercise, I think. Brandon says yes. Are you saying yes to the idea of me doing a video for setting up on Linux? Yeah, so I thought I could get this to work and I can't, so I'm just gonna go back to saying fmap ka. Got a little bit in the weeds here. I don't need this in. Let's refresh that. Let's add the monad testing module. Test, join, test, and then test, bind, flipped. Okay, pass. So let's do this thing, Kleisli composition. Implement composition within the monad environment, pronounced Kleisli composition. So is it proper to say for a monad it's in an environment, and for applicative you say it's in a context? When I've read about applicatives, I always hear the word context used. Trying to look for an example. Oh no, I guess they say in the environment here. Maybe it's not that different. Brendan says I should do a Linux setup video. Yeah, it would be fun. I'm a Linux noob, so. The @ sign replaces the type variable in the for all. It's a type application, not a value application. I think I'm not smart enough to know what you guys are talking about. Pluminator says, I've made a grave error earlier. Arrow A is the type of a function that takes an A, not returns. Aha. How dare you mislead me? No, I'm kidding. Okay, so then this means arrow A is the type of a function which takes an A. So I guess this isn't specifying what it returns. Or is this saying it returns this thing? Oh, maybe that's... Okay, so this function, which we'll call f, arrow a is, which we call f, is a function which takes an a and returns this, which we'll call g, and g is a function which takes an a and returns an a. And maybe that's how we get, like, basically this is saying a to a to a. Monad arrow a is the reader monad. Okay. Brandon says, I believe Kleisli is the reader monad. Oh, and Pedro is saying monad arrow a is the reader monad. So Kleisli implement composition within the monad. So we'll take some f and some g and then some a, and I need a kc. So it looks like I'm going to need to thread the a through here, unwrap this b, pass it through here. So let's just start. I think to start I'm just going to say GA because I have this A and I have this G. So this immediately is a KB. So I'm going to say I have a KB and I need to do something. I'm going to use the dollar sign here. A to A to A, yes. Yeah, thanks so much for clearing that up. See, this is why this is so fun, because I'm learning a ton from you guys. That's where the nesting functions that take an A and join flattens it. Okay, so then yeah, I have a hard time like forming a mental picture of what flattening this means. Like a list, I can just kind of see the inner parentheses or inner brackets going away. But then for functions, like I can't like reason very well what flattening means. I guess flattening means this. Maybe if I think of this as like this arrow A as a environment, taking this and applying ID to it. I mean, we did this walkthrough, right? And we demonstrated that GX is like +7. Yeah, if we did ID the plus, whoops, then binding on plus. I mean, bind doesn't take 3 arguments, so this is kind of, yeah, I think you see what I'm saying though. I was just replacing these values, this expression with, yeah, maybe I should write it like this. Plus is into A, join plus is into A. Let's just show that. Plus, yeah, I mean, you can think of this as into A, right? and then the type of join plus is A to A. Whoa. So I guess, yeah, so you're flattening it. You're like taking an arrow away, but you're retaining the... It's like you're retaining the effect of it. I mean, maybe the intuition to glean is just if you join on a function, you can join a function which takes like 2 parameters or 2 arguments, and instead you can turn it into a function which takes 1 argument. It's like it takes the same argument twice, so you can kind of change the signature. A function that takes an int and returns a function that takes an int and returns an A. When joined becomes a function that takes an int and returns an A. Yeah. It also becomes an int. Yeah. Retaining the effects and taking an int. Yeah. Yeah, with a lot of this Haskell stuff, I feel like I can kind of get it. I can kind of see. And if I walk through this example and just go each step by step, I can prove to myself that it does what the tests and what the types and everything says it does. Yet, and I know I use this word a ton, like I just don't have the intuition. Like, I think it's just going to take some time working with it to develop that. Is that, do you all think that's true? Like it takes time to feel comfortable with it? Or is that just something that stays kind of ephemeral and you just kind of know that it works, but you don't really feel like you you know what I mean? I don't know if I'm explaining very well. Illuminator says, to be honest, join plus is probably not very useful. Okay, well that's that's all right then. It was still helpful to like think through it as an example, I think. But yeah, I mean, join plus is not something you would do a ton in practice. Is there a better practical example? Something you might come across in the real world? Fluminator, I have to recollect everything from first principles all the time. Is that is that like a is that kind of like a bad sign though? Like, is it a weakness of the language, or is it just kind of telling of how lofty the abstractions are? Maybe that's why. Like if the language, if you're using Haskell and you have to kind of stop and think from the bedrock and think from the basic principles and build up. I mean, I guess you do that with other languages too, though. You get into the spot where you really twist it around and there's a lot of complex like logic. You still have to do that, so maybe that's not really a criticism. Hmm. I still get the sense though that we're like arming ourselves with these really lofty abstractions that have this incredible expressive power, proven by the fact that later in the course you create a JSON parser. Okay, so let's try to tackle this Kleisli composition thing. So I have this, so I apply this G to this A. So this should be a KB. And I'm going to throw a hole here. So let's look at this hole. So this should be a KC. So KB is a KB. I need to return a KC. I have this F, which takes a B and returns a KC. So I could F map that, right? On the KB. No. Oh, I need to flatten it. I need to join it. Maybe I should just, instead of, so this returns a KB, maybe I should just bind here instead. So if I bind here, I always type that wrong, then this should be a regular B, and then I would just say FB. Oh, hey, Pete. Pete says, it's odd. I feel like I still don't fully understand reader monad instance on an intuitive level, to be honest. But I know how to refactor some code to use reader T. Yeah. There's going to be some, well, first let me see, reader. There's not a reader T, but there's a state T. To be honest, I don't really understand the T like suffix. What does that denote when there's like a T at the end? Pedro says the last two messages from Plumeria nail it, so let's read those. Reader would be for passing the same config, say, again and again to all your functions. I get it now. In join, we pass the X to both the functions we joined, and you can keep joining functions like that, and all of them will receive X. That's basically like your application config object that goes as an implicit argument to all your functions. Oh, okay. So then, Nate, we could think of join as joining a bunch of functions together. How would you chain like a bunch of joins together, like you're saying? Keep joining functions like that. Pete says T is for transformer in monad transformer. Oh, okay. Don't worry about it. Be introduced to state T. Sounds good. Okay, so Plumenaires, it's usually bind, not join. Yeah. So, I mean, bind does the joining inside of it. So, I suppose for OL for functions. Okay. So did Kleisli pass? Let's see. Test Kleisli. Yes, it does. Okay, so then this can just be F. whoops. What about this? Can we do like this? Move the A. Yeah. Okay. So Kleisli is like pass the value through G and then bind that result and pass it through F. So let's run this in the console. So we have, well, so we have a function that takes an n and returns a kn, or like a list of n. So this function return 2, 3 nil. And then if we Kleisli compose that with this function, which just returns in concatenated with itself, then yeah, so this one does this returns a k, like a k of int, a list. And so does this one. But it's not going to return a list of lists. It's going to be joined or flattened. So, because it's going to bind this result 2, 3. So it'll take the so initially it will be like a list 2, 2, 3, 3, and then that gets flattened because this Kleisli compose uses bind under the hood, and because bind for lists uses flat map. I mean, that's so crazy. I mean, just this little operator is doing so much work for us. It's kind of nuts. Because it's using this and compose, and then that's using flat map, and flat map uses it uses regular flatten and map. It's cool. Pluminator, auto mod like blocked a term. It thought that was a bad term. It's funny. No automod, that's not a bad word. Maybe you need different variables, Pluminator. Bind, join. Pete says, Peter says, I think of the applicative instance of a reader as passing the same argument to many functions. Yeah, okay. It's the S combinator. Yeah, the applicative instance of reader, as we saw, Pedro pointed it out last time, that's the S combinator. You can call it distribution over application. Yeah, it came up on Twitter at Sliminality. was talking about this, and yeah, it's funny it came up because we like literally were talking about that on stream, like right before. Not sure that it should be called that. That's what I call it. Okay, fair enough. So let's do the tests and test monad. Okay, all passing. So now I'm going to pull up the solutions and compare. Honestly, that didn't feel as bad as applicative. Somehow applicative seemed harder. I bet there's always someone talking about it. Yeah, there probably is. The internet. Bind exactly one. Okay, we did that the same way. Yep, flat map. And then for optional, he's bind optional. Let's look at that actually. Somehow that feels like cheating. So it just unpacks the thing and applies the function. Yeah, fair enough. Let's see. Monad. So he says F bound G is equal to lambda takes an X. Yeah, so maybe this is better, more expressive way to write it. So if we redid this, so then we can take the X away here and put it on this side. And then rewrite this as infix. So I guess you'd read this G bound to F. This is equal to a function that takes an X and applies G to X and F to that result to X. So here's an example. I think that this is part of the reason I was getting confused, because see, this function takes two arguments, multiply, and plus 10 takes one. So I guess what you're saying is bind the result of this to one argument and then use 7 as the other argument. So this would be 17 and then 7. So then 17 gets bound as like the first argument to multiply. And then 7 is the other one. So it's 17 times 7. The return of bind takes one argument. That's true. Yeah. So can I just keep doing this? Like, can I just bind this again? Yeah, I can. What? I was gonna guess this would be 119. Oh, it's 119 plus 7. Oh, wow. So if we just keep doing this, it'll just keep adding 7 to the former result, the previous result. Wow. In the end, you always have a function that takes one argument. Yeah. All the functions in the chain take 7 as the first argument. Yeah. Can we prove that by saying minus? Because if 7 is the first argument, then it should be negative. I think it's actually the 7 is the second argument, right? Maybe because we're using this left bind? Or maybe it wouldn't matter. Pedro just says, you just found out that you can press 1 plus in the calculator, and then you can just keep on pressing plus. Yeah. So you open a calculator, hit 1 plus, and just keep doing that. I guess. No, if you just keep hitting the plus button, it just keeps adding 1. So let's try flipping this around. So let's take this one. I'm going to change these into regular bind. So in this case, the first one has to be the value. So I'm just going to use all pluses since that seems easier. So 17, this would be 17 plus 7, and then plus 7 plus 7. Okay. Wow. So this is basically just saying like plus 7 plus 7 plus 7. So then if I bind this to minus, what? Oh, I left the multiply in there. Let me move the text up. Yeah, so 7 is the second argument either way. All functions take 7 and return something. It's really neat. Yeah, I always learn things when I go through these solutions. I think what I want to do though is I want to keep the way I had it and then put the other way in a comment. Just keep both. Okay. Let's look at this apply that we did. We re-implemented apply. Wow, so he used this right bind, which is weird because that comes later in the exercises. So now do list. I don't understand. So F, you bind F, because F is a, oh yeah, his solutions are old as well. It's like an old branch of the FP course, because now it says monad K. So gets this F of A to B, so we bind that, and now we have this A to B, and then we bind the A, and now we have this A, and then we apply F prime to A prime, and that should give us back a B, and then use pure to wrap it back up. So yeah, this is a helpful way to express it too. Yeah, I think he's doing it this way because it's giving you a different kind of way to think about it. Walk through the list monad like you did reader T. I mean, only half serious. Okay. The list monad. Ugh. Excuse me. The list monad. Is it really that bad though? I mean, I kind of did walk through it here, right? Oh, lists. Yeah. Yeah, so if we have so like this example is like a function which takes a value into a list. And if you bind the list to it, if you just applied, if you like fmap this function, then you would get a list of lists. But because you bind is flat map, so it's just a single list. But what does it mean? Yeah, exactly. Binding a list. Yeah, I don't really know why. Like, I guess it means that you're flat mapping. Binding a list. Yeah. It's almost like binding is almost like getting inside the it's like extracting a value like out of an environment or out of a context. I mean, that's kind of the feeling I get here where it's like you have an F and you bind, and then it's like now you've gotten inside this F context to this function underneath. Same with the A. So it's like fmap, it feels like you're injecting a function into a context. Whereas with bind, it feels like it's like you're pulling it out. But that intuition obviously breaks down because, I mean, I think that's why the instances for function for reader are so mind blowing, because it's just like it doesn't really fit that intuition. I mean, you can sort of do these kind of semantic gymnastics to kind of make it fit that intuition, I guess. Yeah, but what does it mean to extract the numbers out of a list? Like in an optional, it's like you're grabbing it out of a. I guess what it means is for list, it's like you're opening the list and seeing if there's any elements in there. If there are, there you use them. Hmm. I didn't expect this to actually be that insightful. The train of thought I'm having is like, yeah, for fmap or mapping over list, it's like you're injecting a function into a list and you're saying do this to each one. But bind is like crack open this list. If there's nothing there, then just you're done. But if the values are there, then I want you to transform the list this way. But it's different than fmap because it's, I don't know if I'm making any sense. Illuminator says join takes a mechanism that generates a mechanism that generates a value and gives a mechanism that generates a value. So join takes, joins two mechanisms together that have different arities. Mechanism for reader is giving the same arg to all functions. Okay. Mechanism for list is apply a function to multiple values. Yeah. Perhaps. So let's see what else we can learn from Tony. Join. Yeah, so he just did bind ID. Does that help us think through it? I suppose you could also write this like so. Let's try. It does pass. So join is like just do ID over. Okay. So if we continue thinking of bind as like reach inside some context and pull the value out, then join is like, and after you pull it out, just return it, right? Just ID. So let's go back to the type of join plus. Yeah, so it takes an A and returns an A. So yeah, so that intuition I'm trying to think of is like, it's like reaching inside some data type, some container or wrapper or context, and then taking the value out. It's kind of breaks down because functions, it's like, but I guess if you're thinking of it as reader T, like a reader T is, so it's like, should we go back to, let's look at this way he originally has it. So this function is from like an A to a reader T. And then you take a reader T of A, you return a reader T of B. So when you bind on a reader T, it's like you're getting the A. It's just function application. So the way you get an A out of an environment of reader T is just like apply T to some function. And the way you get, okay. So, and then X becomes like our T. I don't know if I'm making sense. A T taking function. Yeah, so to get the A out of a T taking function, you provide it with a T. So binding this is like you're grabbing this A out of it, which, and then you pass that A into this function, and you get another reader T, which a T taking function which returns a B, which is this, and then you give that thing an A, and you get a B out. Yeah, I have to mull on that one. It's not a very fun stream, just like sit here watching me think, but maybe we're thinking together. So, okay, let's finish. Let's see what else Tony has for us. So then bind looks like the same. Yeah. And then Kleisli. Is Kleisli usually written the other way? I know this is called the fish operator, but maybe usually it's the other way. So this is the first argument. Pluminator says you're binding to ID though in join. Yeah. So if you have a reader T, like a T taking function that returns an A, you take the A out and bind it to ID, then you just still have the A. So yeah, so in this case, so if we name these things and say this is F and this is G, when we join on the plus, 7 becomes like our A, this like value that we're like reading, I guess. So we feed 7 into this thing, and we get a plus 7 out. I don't know. Yeah, it's bizarre. So binding on ID. Seven is T. Okay. But if you just say like just join on plus, there's like no 7. So it's just saying like you were going to take this A. I guess it's because it's deferred. Maybe that's why it's confusing. You're going to take this A, which is the result of applying some function, and then you're going to transform that into a function. So that eventually, so the way that Tony wrote it is like this. So binding G to an F is like you're taking the result of this G and giving it to F, which returns a function. So which then you end up giving the same argument to F that you gave to G. So it's like you give, so if yeah, so if we're saying join plus, it's like binding plus to ID. So it's like +7 we take the result of that, so +7, and then we bind that to ID, so it's just +7. Yeah, so it's kind of like, yeah, it's hard to explain. But G is not ID. That would be 7, right? F is ID. I think. Yeah, so then F becomes ID, and then G is plus, and then X is 7. So then okay, so maybe this is why. So plus in this context, A is also a function because if we said A is like int to int, yeah, so it's like this, right? So then that type from bind, I'm gonna pull it down here. So then plus, if we try to think of plus in these terms, so like plus is like a function which takes a t and returns an a. So it takes some num, but then what a is like num to num or int to int. So it's like we're extracting. Huh. Plus is like this function that has a function hiding inside of it. That's kind of the way I'm thinking of it. So let's go back to this regular plus and think of it like this. So, okay. Yeah, Pluminator says the taking out things seems not very apt to the function monad. Perhaps, but hang with me for a second. Maybe I'm doing the thing where I'm doing like the semantic gymnastics to like coerce it into making sense. Which, yeah, I mean, I concede that, but for some reason it still feels helpful. So if we think of plus as like this reader t. So think of it this way. So plus has like this function in this reader int environment. So we can like extract this function out of plus by providing it some int, which is just partial application, right? So then the result of so like taking that out of binding that, it's kind of like extracting it from that context, this reader int context. And then we apply it to this function, which is ID. So it just returns this function. But the thing is, like in this function has like a closure in it, right? It has this 7 closure in it. Anyways, yeah, maybe I'm just doing some like semantic gymnastics. Let's see how he wrote Kleisli. So FG, yeah, I guess he wrote it, shows a lambda. Apply G to X and then bind the result to F. I mean, it's very similar to it's like nearly F composed with G. It's got this bind in the way. Cool. Yeah. Realize the taking out, like extracting thing, it doesn't really work for functions, but I feel like these discussions are kind of like taking some problem or some concept and just turning it over in your hands and like trying to look at it from different angles. And even if you're saying nonsense, like you're still thinking through it. So yeah, I feel like if we have this like add xy, we say x plus y. And then we provide like 7 to add. Like the result of this is like take some y and add 7 to it, right? That's kind of what I mean is like you can bind this maybe you're taking the result of applying the first argument of many. Yeah, in this case, taking out is application, right? You're eliminating a function by applying it, or you're eliminating this first argument. It's like you're or with other binds, like so with optional, when you bind an optional, it has this sense of like, or list, it's like you're unpacking it. It's like you're checking if it's empty. Or with exactly one, or it's like binding is, it's like you interact with that element, it has some consequence. That's the feeling you get with these declaring instances of type classes, because these types, these values that you're working with are so abstract. Especially like these ones at the bottom, where it's just like you don't know what these things are, so you just have to be super abstract with your implementation. But binding to some monad is like, it has the feeling of like you're unpacking it. It's like you're given this box, just like this monad, and you open it and it's like there's some consequence of doing that. Like if it's a list, if it's empty, or if it's optional, if it's empty, then it's like, oh, it's just empty. That's like, I'm done. But in the case that it's a function, it's like, now I need to go one level deeper in the function. I need to like apply it once. Or maybe if it's like an either, and it's like the error, it's like left. Yeah, I don't know. I'm just yammering. Just yammering. But it's really fun. I mean, I feel like I'm learning a ton by doing this. Which is kind of the point, I guess. Test monad. Cool. Well, any last thoughts? What other thoughts about monads? Are we hungry for burritos? Guys want some burritos? Automod still like holding back. Holding back this code. Pluminator wants some burritos. Yeah, I could go for one. Yeah, for those not in the know, like I guess there's some famous monad tutorial. Monad burrito origin. It's like someone made a tutorial that was like monads are like burritos and tried to just explain monads in terms of this analogy and just took it like way too far. First, I like monads are like burritos. Oh yeah, I'm not gonna this could be a really deep rabbit hole. Yeah, the monad tutorial fallacy. People begin with the concrete and move to the abstract. I think that's why I always like want to take these things and try to do some concrete example of it, you know. I think that's a pretty normal thing to want to do. But so Pluminator is saying we should write this as a lambda instead. That might be helpful. Bind FG. This one. Yeah, I think that's what the solution, Tony's solution, did. So yeah, he writes it like this. So when you bind f and g, you get back a function which takes some argument and applies it to both. Plus t plus t. Yeah. Yeah, maybe maybe in the future, like we could do this live share, this VS Code live share thing. And then you can just type in my editor. Be fun to do. I do need to get my new like setup first. I'm gonna get set up on Linux, and it's a much faster computer. And then I'll get a mic. I mean a better camera, and then I could stream at better quality and have like a phone call, screen share going at the same time as streaming. And that'll be good. Pluminator is bind. So when you bind plus to ID, it's like you're getting ID of plus t to t. That would be lit. That would be lit, fam. Let's do some mob programming. But yeah, I think that's going to be it for me for the night. I'm actually quite pleased we got through a stream in less than 3 hours for once. I'm actually kind of surprised that this felt like, I feel like applicative was much more challenging, the exercises, and I feel like there's more of them. I don't know if that's true. Certainly felt that way. Oh, and this filtering thing was really hard. Sequence, yeah, sequence took a while to wrap my brain around. And filtering, yeah, it's really challenging. Okay, but that's going to be it for me. Thanks for joining, everybody. That was really fun. I feel like I learned a lot. I think I'm also going to start trying to stream on a more regular schedule, like Monday, Wednesday, Saturdays. I'll put I'm pretty sure that's what I'm going to go with, but I'll throw it on my Twitch somewhere so people can see. But yeah, thanks a lot. I will catch you next time.